Okay, so having collected all these terms here, we get this equation. So, and I'm not sure where I left off before, but there is no t to the fourth on the right, so that the 6c4 has to be 0, meaning c4 has to be 0. There's no t cubed on the right, so that this expression has to be 0. So we have this expression equals 0, and since c4 is 0, c3 also has to be 0, meaning that we never needed the c4t to the fourth or the c3t cubed. And that is, and should be, kind of obvious, since if we did have the t to the fourth, c4t to the fourth, then this 6y term would give us 6c4 t to the fourth on the right-hand side, and we can't have a t to the fourth on the right-hand side, meaning c4 from the very beginning would have to be 0. And you can reason similarly and see that c3 also has to be 0, because this term would again give you a t cubed on the right, and you can't have one. With t squared, though, the coefficient of t squared here has to equal 1, since the only way you're going to get a t squared out of this expression on the left is for this whole expression here to equal the coefficient of t squared here, which is 1. So we can say that 6c2 plus 15c3 plus 12c4 t squared has to equal t squared identically. And it then follows that this expression here has to equal 1. But since c3 and c4 are 0, we get 6c2 equals 0, because these two terms are just going to go away. Then our t term, well, the coefficient of t has to be 0, and this constant term has to be 0, because you have no t over here, you have no constant term. So you get 6c1 plus 10c2 plus 6c3 has to equal 0, and 6c0 plus 5c1 plus c2 has to be 0. Now, of course, we know that c3 equals 0, so we could rewrite the system as 6c2 equals 1, 6c1 plus 10c2 equals 0, and 6c0 plus 5c1 plus c2 has to equal 0. Didn't exactly line that up well, but you see we can then just solve this system by forward substitution and find the values of c1, c2, and c3. So we solve by forward substitution. That gives us a particular solution, which we can then add to the homogeneous solution. So our general solution when we find our C1, C2, and C3, the result will be our particular solution, which I'll call y sub p. So I'm going to put a sub p on here now, since I'm talking about the function. We add this to the general solution. Of our original homogeneous equation, and we get a general solution of the non-homogeneous equation. Now, it's not always possible to do this for any function you have over here, but it is possible, and actually very easy, although it might get really messy, for any polynomial function. You just take the highest power you have here in this polynomial, and that's going to give you your trial solution, and you solve for the constants.